Hello, welcome back, and today we are going to solve the series of n factorial divided by n to the n power. The question is just asking, is converge or diverge? We don't have to find out which value does it converges to if it converge. So we are also provided that the limit of x approaching infinity 1 plus a over x to the bx is actually equals to e to the ab, and I have also did a video proving this to you guys. You can watch it in the description. Okay, so let's start. First of all, we have a ratio, so maybe it is good to use the ratio test. The ratio test means when n approaching infinity, the absolute value of a n plus 1 multiplied by the reciprocal of a sub n, if it is less than 1, then the series converges, and this is the ratio test. Okay, so now we would like to work out the absolute value of the a sub n plus 1, which is n plus 1 factorial divided by n plus 1 to the n plus 1 power. The n becomes n plus 1 because we want a sub n plus 1, and then the reciprocal of this series, which is the n factorial, goes to the bottom, and then n to the n power goes to the top. So now maybe we can do some simplification. First of all, the whole thing here should always be positive, right? So that we can ignore the absolute value. n plus 1 factorial is not good because we want n factorial, not n plus 1 factorial, so that it can cancel out. But that's not a problem. N plus 1 factorial is equals to n plus 1 multiplied by n factorial. Agree with me? Yes. And then n plus 1 to the n plus 1 power, let me keep it the same. So now the factorial cancels out, and these two cannot simplify, but we can write this into n plus 1 multiplied by the n plus 1 to the n's power. It is the same. And then we are left with these two cancels out. We're left with this, and then maybe we can take out the n power. We are left with here. So now we did the simplification, but can we do anything? Not quite, unless we are provided by this. Why is this useful? Because we can now write this into the form 1 plus a over x to the power of bx. Just use your brain, and then you will know how. We can actually flip the fraction, but we need a negative power so that it will make it reciprocal. This right here is equals to this, and then we can split the fraction into 1 plus 1 over n negative 1 times n. So now a is equals to 1 and b is equal to negative 1. We can compare the coefficient. So we can now write it to e to the ab power. A is 1, b is -1, so it's -1. So it is the same as 1 over e. And 1 over e is less than 1. We can already draw our conclusion, since the absolute value of a sub n plus 1 multiplied by the reciprocal of the series is lesser than 1. In other words, 1 over e is less than 1. So the series of n equals to 1 goes to infinity of n factorial divided by n to the nth power converges. And that's it.